Okay, so this is a quick video to go over the rubric that we're going to use this semester, and also to try to highlight what the TAs have been instructed to look for in grading your lab reports. So if you look over on the right in this Prezi site, you can find the rubric that you should download. This is also available in Canvas. This file, you need to print it out and staple it to the front of your lab report each week when you turn in your lab report. Okay, so a blank version that the TA will then fill in as they go through grading your lab. All right, and so we'll go over each of these sections in some detail, try to explain what we're looking for, and again, I'm trying to keep this video down to like a 10-minute clip so that it's not too onerous to listen to. For this lab, we are very concerned about quality of writing, all right? And so this is your ability to communicate scientific information. You're mostly upper level chemistry students at this point, and so that should be a skill that you leave here with. So we're gonna look at things like the presentation, neatness, clarity, language, what level of the technical discussion you're achieving, and then grammar, literally spelling, punctuation, grammar, tense, okay? So all that is going to count in these lab reports. The next section is the introduction. There should be a brief background on why you're doing this, what problem you're trying to solve, or what question you're trying to answer, and really sort of maybe putting this in the context of a larger body of work. So if you're doing capillary electrophoresis, for instance, and you're measuring caffeine and aspartame, you might think about why you want to measure caffeine or other components that you're going to measure in the lab. You might think about how CE works, what the origin of CE is, of capillary electrophoresis is, and really what the fundamentals of how the measurement is performed are, okay? So this is an instrumental analysis lab, so we're interested in the context of the experiment, and we're interested in how the instrument that you're doing the experiment with actually works, okay? It's perfectly fine to have a schematic. It's actually preferred that you have an instrument schematic at some point in these lab reports that explains how that works, and that'll help you when you're trying to describe what's happening. You can refer to that figure. All right. The experimental portion. That's a description of the experiment design, how you'll answer what the question you identified in the first part of the introduction, how you're going to address answering that question, doing the analysis in the lab. There must be enough information in this portion that if somebody walked up to a similar instrument, they could repeat the experiment. For instance, if you're doing the HPLC lab, you have to know what column you used. You have to know what flow rate you used, what solvent composition. And by solvent composition, I mean like the ratio of like methanol to the buffer and what the buffer was, pressure, things like that. So anything that somebody needs to know. And then this also includes the methods for the experiment. And so we're considering that in this section too. Results and discussion. You should put the most important things at the beginning, all right? You need to interpret the data here. Don't just present it. So don't just say what you saw. Explain why the results that you saw happened. Okay, does that make sense? Or what the relationship is between different factors. For instance, if you looked at mobile phase composition and how the mobile phase composition impacted a separation, talk about that, okay? I mean, why did that happen that way? Really, we want to see that you put it in context of everything else that's going on, and so that, one, the reader understands the significance, but also that you demonstrate that you understand the significance. And your results may include visuals such as tables and figures. I'm going to talk about that more at the end. This says may. I'm actually going to require that you include visuals, tables, and figures in your lab reports, okay? So I'm very concerned about that, because that's a skill that you need to have, the ability to prepare a clear figure in a clear table. The results and discussion section, you're going to interpret your key findings. Anything that didn't happen the way that you thought that it should, you're going to talk about that, and difficulties. And then every measurement has inherent error. You can talk about errors that you made, errors in the instrument, and how you could overcome those errors in the future, or how best to account for them. Finally, in the conclusions, you're going to summarize the key things that you learned in this experiment, and you want to make any recommendations to somebody that's going to do the experiment in the future, trying to replicate it, things that they might want to know when they do that. Okay, literature cited. For these labs, you must use ACS formatting for references. There's a link to the ACS style guide included in this Prezi. We're going to require that the reports have 3 outside sources. These outside sources should be primary literature. So it should be a referenced journal article, something like Journal of Chemical Education is okay, Analytical Chemistry is okay, The Analyst is okay, Analytical Methods is okay. All right. So these are what I'm talking about. Primary literature journals. If you're not clear about what that is, come and ask us. We'll clear it up for you. You must cite 3 outside sources, and it should not be the lab procedure. All right. You can cite the lab procedure, but that's not going to count as the 3 outside sources. And then you can also use additional referencing as needed. You should use additional references probably. All right. The appendix, like I said, you need to earlier in the semester, I said you need to photocopy your data, or photocopy or take a picture of it and include it, append it to the end of your lab report. And any discussion of fundamental theory that you want to include, that you can reference in the introduction, you can include that there also. Finally, figures and tables. Figures and tables here, they must be prepared and formatted from original data, meaning that this has to be XY type of data, not just that you cut and paste an image from the instrument output. Okay, so you need to go into a program like Excel or Origin or whatever, Python, and prepare the graph that you're going to use, or the graphs and tables that you're going to use for this from the original data. Okay. I'm going to give you some examples of what we are looking for in figures. Okay, so here's an example of a figure, and this is taken from the primary literature. This is actually a publication from my research group. You need to have the x-axis labeled, the y-axis labeled, units that are clear, units that make sense. There should be a border all the way around the data. And there should be tick marks at the major points on the axis and tick marks at the minor points. Those should be present on the top and the bottom. And that's so if you lay a ruler across this, you could actually try to extrapolate this data. Okay. There have to be units on the labels for the axes, and whatever kind of trace that you're showing, there has to be a legend that describes what that trace actually is. You can have more than one trace in a plot. That's fine. Then you need multiple, more complicated legend. All right. You can also label any peaks that you see if you're interested in doing that. Anything to help clarify it for the reader. We're going to be very, very picky about figures this semester. Okay, so if you have bad figures, or if your figures are of poor quality, that is something we want to try to improve. Okay, here's another example where we have data that's a little bit more of a, it's not a primary data, but it's where things have been taken out. For instance, you could think about this as similar to a calibration plot in some cases that you might make. All right, but here you'll notice the same things happen. We have labels for the X and Y axis. The units are shown. There are labels for the individual tick marks on the axes. There are sub-tick marks. The border goes all the way around. There's a legend that shows what is actually being measured. And that's present in all of these, depending on, it's independent of if it's a bar graph or an XY plot, okay? So again, we're going to be picky. At the end, underneath this, right, you should have, it should say figure 1, for instance, and then you should actually have a textual description of what this figure is, all right? So I want you to make very good figures with these lab reports, all right? Same thing with tables. The tables need to be clearly produced and straightforward, aligned well. And you need to have units on any key categories or columns and entries into the table. All right. So the table should look nice. They should be formatted from from the primary data. And again, we're going to be taking paying close attention to this when they show up. All right, and then at the end of the rubric, the points are broken down into how many points per section, and then what percentage that is out of the total of 100, and then we'll scale that to be an appropriate value with a lab report, for each lab report as it's indicated in your syllabus. Don't be late turning in lab reports. The penalties are steep. The TAs are going to work hard to keep up with the lab reports this semester so that you get feedback early and often. If you need help, ask questions and get help. We're always available either in lab, there's lots of time to talk about stuff, or you come to office hours, either mine or the TAs. All right, thanks.